Welcome to Introduction to iPhone Development here on TechPub. Today's episode 6, the good, the bad, the ugly, working with SQLite and an iPhone application. What you see might surprise you. And today Ben is going to show you two ways of working with SQLite. One, the scary way, where the API kind of gets a little bit out of control. And then the second way, a little cleaner, using a library called FMDB.
Hi, and welcome back to the iPhone Development Screencast series for TechPub. I'm your host, Ben Sherman. Today we're going to continue our to-do list application, but this time we're going to persist the items using SQLite, a lightweight database for the iPhone. So SQLite is a single-user, file-based, simple database that's cross-platform, and while it doesn't support everything that ANSI SQL provides for most database servers, it's really easy to use, and it provides most of the things that you would want in a database. SQLite comes with a pure C API, so one of the first things that you'll notice is that it is quite a bit hairy to work with. The API is not necessarily as friendly as some of the Objective-C Cocoa libraries that you're used to, nor are they as friendly as any of the ones you're used to in, say, .NET or Java. There's a lot of strange-looking, hard-to-debug code, and ideally we'll just tuck that away in some classes, and once they work, we'll just trust that those work, and we won't let the SQLite code bleed into the rest of our application. After we've examined how to leverage SQLite, we will go through and look at one of the helpful libraries that help abstract it away for you. But I think it's good to understand the concepts, so we will start with writing SQLite code from scratch. So one of the first things that we will come across when writing database code in the iPhone is that by default, your app bundle is signed. So when it runs on the simulator, things might work, but when you deploy your app to an actual iPhone, you cannot write to any data or change any of the contents of your app bundle. And that poses a problem with the database that we expect to write to. So how do we solve this problem? This is a picture of what your app sandbox looks like. You deploy your app bundle here, which contains code and a resources folder, and that's signed, and none of the contents can change. But your app is also given a private documents folder, which is intended for us to write content into. What we're going to end up doing is copying the database file from resources over to documents. Now you have to be a little bit careful here and make sure that you only copy it if it hasn't been copied already. Otherwise, you'll be overwriting their local database every time you launch the app. We also have to be cognizant of the fact that we might want to make changes to this schema over time. So I'll talk about, at the end, we'll talk about some techniques on how to accomplish that without ruining the current user's database. So quickly, let's go through and talk about ways of creating our database. Okay, to create our database, we're going to go into our project directory in the terminal window, and we can take a look, and this is our standard Xcode project directory, and we're just going to add a new SQLite database file here. And to do that, we can use the SQLite 3 terminal command and the name of the database. So I'm going to call this todo.db, and that's going to bring up the SQLite terminal. And this is a way where we can create scripts. We can run scripts, we can insert data and create tables and all kinds of stuff. It's not necessarily friendly if you're not familiar with SQL, so after this I'll show you another way where you can manage a SQLite database. To start off with, let's talk about some quick SQLite commands. The first things first, knowing how to exit is always important, so just hit .exit, and we can go back into it with the up arrow. Okay, so now that we're in the SQLite thing, we can type .help, and that will print out the help. You can type .tables to list out the tables, and .schema to list out the table schema. Okay, so we're just going to start off writing some commands. So let's create a table called to-dos, and we'll have some columns in here for the ID. This is going to be an integer, primary key, and we're going to say auto increment. We need some text for the to-do title, and I'm going to just say that's in varchar of 100, and then we're going to create a completed column, which is a bit field. Okay, so now I've created my table. I can look at .tables and see that I have to-dos, and you can do .schema, which will show our schema. Now we can insert some test records into here. So let's insert into to-dos. We're not going to specify the primary key because that one will be generated for us. So we just need text and completed. And the values for those will be item 1, 0. And let's do item 2, 1. And item 3, 0. Okay, so now we should be able to say select star from to-dos and we get our data. Okay, now we'll exit. Getting the resource path is useful because we're going to bundle our database inside of our resources folder. And so we can use this snippet of code, basically calling path for resource on our bundle. And we pass in the first part of the file name, and then this extension comes in as the of type parameter. So if you pass in a string that has the file name, you'll have to extract out the left part of the file name and the extension so that you can call this method. And that will return the iPhone OS resource path for whatever resource you're choosing. Then for our destination directory, we'll actually need to find the documents directory for your app. And to do this, it's a little bit confusing, but this is the traditional way of doing it. You call ns search path for directories and domains, pass in the flag ns document directory and ns user domain mask, and that will return an array of paths, and your documents directory will be the first object in that folder. So I like to make this a helper method so that I don't actually have to write this code too often. Over here in the resources folder, we're going to add existing files. And there's our new database file we just added. Click add. And since we're already in the right location, we do not want to check this copy items into destination group folder. If perhaps you had created this outside of the project root folder, then you would want to check that. So then we say add, and then we should have our todo.db file here. Okay, so now it is time to take a look at the SQLite API so that we can actually connect to this. The SQLite homepage has a bunch of examples of how to use it in various platforms and languages. You can download it for various platforms here. If you haven't downloaded it yet, go scroll down and do the precompiled binaries for Mac OS X and download this one right here. This is what gives you that terminal program SQLite 3. Then if you go over to documentation, this will show you, the SQLite in 5 minutes or less is a pretty good way of getting an idea of how we can utilize this API. So on your project, in order to use SQLite, we're going to go over to the frameworks folder. We're going to right click and we're going to say add existing frameworks. And then we're going to scroll down and find the libsqlite 3.0.dylib, and we're going to add that to our project. And this is basically going to give us the SQLite API. Okay, so the first things first. As we talked about, the documents directory is the place where we want to move our database so that we'll be able to write to it. And it's very important not to skip this step because things will work in the simulator, but they will not work when you start doing an ad hoc build and putting this on an actual phone because your app bundle that you deploy onto the phone is signed. So what we're going to do in our app delegate is we're going to copy the database if needed, and basically initialize the database. And to do that, let's go ahead and create a new class here. And we'll call this to-do database. And the first thing, I'm just going to create a function here to say make writable database, and then we'll use that as a way that we can create our database, put it in the users folder. Okay. So I've already included a couple of helpers here, helper methods for getting the path for the resource and the documents directory. And those are implemented like this. And these are just basically plain C functions that use Objective-C code. So there's no actual class here. So basically all I have to do is import this header file helpers, and we can utilize that elsewhere. So in here, I will import file helpers, and I also need a database path name or file name, and it's todo.db. Okay, so the first thing to do is check to see if this file is already in the documents directory. So we will get our documents path, and that equals documents directory. And then we can use a string function, string by appending path component, and utilize our database file name there. So that will automatically deal with slashes and such. Then we can grab our NS file manager, and we can utilize that if file manager file exists at path documents path. And I'm actually going to rename that target path, which seems a little bit more clear. Okay, so I'm just going to log a statement, file already exists in documents directory, and then we return because there's nothing to do here. Then we can say file manager. We actually need to get the source path. So in a string source path, and for that we can use path for resource database file name. Copy item at path, source path, to path, target path, and for now we'll just do no error checking because it's a simple application. But in your own, you might want to check, pass in a pointer to an error instance here, and then check to see if the error is not nil so that you can output an error message. Let's get rid of that const to change that error message for now. Okay, so now we have our basic structure for copying this over. And let me just add a log statement so we know what's happening. Okay. So now let's go ahead and go into our to-do app delegate, and we're going to import this to-do database class. And we're going to say to-do database make writable database. Okay, so in this case it should copy the todo.db from the bundle path to the documents directory, and it does. And you can see that we still have our items from last time in there, but we'll go ahead and remove those now that we have some test data in the database. Just to make sure, let's run it one more time, and we should see that it does not copy the second time. File already exists in documents directory. That's an important step. You might bump your head on this a couple of times where you're accidentally copying this every time and thus overriding any changes that you made to the data during the last session. Okay, so the next step is to, we're going to show the listing of the to-dos. Let's go ahead and add a method for that to get the to-dos out of the database. So we will create a method that returns NSArray, and we'll call it fetch to-dos. And we're going to utilize the SQLite API here in order to get the to-do items out of the database. And this is going to be quite involved, so let's just dive right into it. The first thing you need is a SQLite 3 object, which we can use by importing Now that we've imported this header file at the top, we can utilize this SQLite 3 object. We're going to call it DB And what you'll notice is that a lot of these functions call SQLite, or start with the prefix SQLite 3. So we're going to call SQLite 3 open. We're going to pass in the file name. Now this is the full file path to the database. And we're going to do this multiple times. And notice we already have it sort of out here. So let's create a method for that so that we can get the database path easily. Okay, so now that we have the database path, I'll make that an instance method and move it down here. Okay, so now we have the database path. We can say self database path, and every single SQLite API function is going to take C strings. So when we work with NS strings, there's a method on it to return a C string with UTF-8 encoding, and that's appropriate for dealing with strings within the SQLite API. And notice this thing, if you haven't ever seen this before, it's a little daunting, but basically it means a pointer to a pointer. So since we've already declared our SQLite 3 DB pointer over here, we just need to pass the address of that pointer here. And basically what that's going to do is this SQLite 3 open parameter is going to actually return a status code instead of the database. And then the way they populate the database pointer that we created is through the address of that variable. Now, if you've never coded in C or C++ before, that probably looks a little weird, but in general, anytime you see the double star as part of a method argument, then it's expecting you to pass the address to a pointer that you have already created. Okay, and every step of the way we can check to see if status is not equal to SQLite OK. At this point we can raise an exception or just log a statement. So we can say error opening database and exit the program. Okay, so now that we have that, we have an open database. Now somewhere at the end of this we actually have to close the database. So we'll say SQLite 3 close and pass in the database pointer there. Okay, so the next step, we have to create a SQLite 3 statement. So let's go ahead and create that. And to create it, we will use the SQLite 3 command prepare v2. We're going to pass in our database pointer. Notice how here it's expecting a const char star for our SQL string. So again, if we're using NS string variables, then we're going to have to call the UTF-8 string parameter. If you just want to do it in line like this, then you can just use regular quotes without the @ symbol in front of it, because this @ symbol means NS string. If we remove that, this is just a regular char array. And so what we can do is say select ID text completed from to-dos. This is expecting the number of bytes of our SQL string, and if we just wanted to calculate automatically for us, we can do -1 here. Then we need again we have this double pointer here, which is a address of our pointer, because it's going to populate our statement pointer. And this PZ tail, for the last parameter we will put null because we're not going to use that feature. Okay, so now we've got our SQLite prepare v2 call. This also returns a status code, so again we can check the status and say if status is not equal to SQLite OK, then we can say log that error preparing statement and then exit the program. Okay, so now we've got a statement and we're ready to execute it. To do that, we can say status equals SQLite 3 step and then pass in this statement here. Now, depending on what type of command you're executing, this can return different things. And since we're expecting this to return either a row or SQLite 3 or SQLite done. If it's just like an insert or an update statement where you're not returning any data, then it would just equal SQLite done. And there's a bunch of other potential things it could equal, like SQLite busy and others. If we want to take a look at that, take a look at the documentation page. There's a bunch of information here about the error codes. Okay, so here are the different result codes that could happen from any of these SQLite functions. The typical ones you'll worry about are SQLite done, SQLite row, and SQLite OK, which is that one. But there are some other cases that you may want to handle. So for this particular example, it's better to just use a while statement here. So we can say while SQLite 3 step on our statement is not equal to SQLite done. Or let's just say while it's equal to SQLite row. And that means there's a row of data that we can pull out here. After the statement is completed, we want to SQLite 3 finalize the statement. Now, if you had some performance considerations, you might actually want to cache this statement and reuse it, and in which case, instead of finalizing it, you would call reset on the statement, SQLite 3 reset, which would reset all of its parameters and allow you to run that on a different query set. Okay, so in this case, we have a row to process. So let's go ahead and create a to-do item. And in order to pull out the various columns on the row that we are on, we can call SQLite 3 column integer. And this one was going to return an integer, so we do statement, and then we pass in the column index. Now this one is 0 based, so I'm going to pass in 0 there. So that means the first column is going to be our ID, and so I can pass in to-do ID equals that. Then to-do.text is going to equal to SQLite 3 column text. Pass in our statement, and then that's going to be column at index 1. And then to-do.completed. Now, when we pull out Boolean values, they're actually treated as integers in the database. So what we're going to do is say that equals ns number with int, pass in SQLite 3 column int, that's going to be index 2, and so that gives us an ns number instance, and then after that we can just call bool value on that, which should give us a Boolean value. Make sure I lined all these up correctly. Alright, so now that we have our to-do, we actually need to add that to an array, so let's create an mutable array to-dos. And then add it to our to-dos collection. Okay, then we finalize it and close the database, and then we return our to-dos. And we're going to auto release it. Okay, this needs to know what our to-do class is, which we can use by importing it at the top. Okay, we actually need to add our to-do ID here. Okay. Now we should build. Yes. I forgot the rule I told you already. SQLite 3 column text is going to return a C string. So what we need to do is say ns string. Okay, so at this point we've built our to-do with our 3 objects. They come off of this row that we're on, Every time through the loop, it will call SQLite 3step, which will advance it to the next row, and we should get the new row of data for the second one, all the while building the array, and then we return it at the end. Make sure you call finalize on the statement, otherwise in cases where you're writing to the database, your writes actually won't take effect until you do finalize. Okay, next off, we have our fetch to-dos function. It creates our database, creates the statement, loops over the items, and returns it. Now let's go to our TechPub to-do view controller. And what we had before was an NS mutable array for these items. And we were actually creating those manually, which we can see. Right here in our constructor. So instead of doing that, what we're going to do is change the type of to-do items to a regular array, because that's what's going to be returned by our database. And let's go ahead and create our database class here. So we import the header file, then we're going to add an instance variable for our to-do database and just call it db. And in our init method, let's go ahead and find that. We can get rid of our add to-do helper here. And instead of creating this array, we're going to get it from the database, which we haven't actually created yet. So let's do that. db equals to-do database, alloc init. And the items are going to be db fetch to-dos. Now we're going to get a couple of warnings here because we changed it from a mutable array to a regular array. So let's go ahead and just change, we'll comment these things out for the editing and deleting of the data. Okay, so now if we run it, it should actually go fetch these items from the database. And we do have a crash. So let's take a look and see what happened. Set to do ID. It didn't like that. We needed to add our synthesize property there. Okay, so what we notice is it's running, but no items are actually here on the screen. So we probably have an error in our SQLite code. Let's go over here to our to-do database and add some logging statements here. So we know that it did not, it did pass these two statements here. And let's go ahead and figure out when it's processing a row. And we should see these log statements in the bottom here. I know what's happening. In our TechPub to-do view controller, we're assigning our database instance, excuse me, the to-do items array to this. We do need to retain it first because it's auto-released, so that will actually crash in some cases. Okay, now we have our items. So our items here, notice how we did set one of them as completed, so this checkbox is automatically added for us. So we do have our database select code working properly. Now I want to add where when we check off these guys, it actually hits the database and updates the record in the database. So let's do that one now. That'll account for both checking and for editing the item text here. Right now we're just obviously editing the in-memory ones. So let's go ahead and add in our TechPub, or excuse me, our to-do database. Let's create another method here for update to-do. And we pass in our to-do there. Add our little import at the top, to-do.h. And we're off to the races. Okay. So a lot of this code becomes duplicated, and what we're going to do there is go ahead and make a couple of helper methods for doing this stuff. So we're going to take this code out, and we're going to implement a code that's actually going to create our database for us. I'm going to call it Open Database. And we're going to pass this in and return DB. And that way we can just say SQLite 3 star DB equals self open database. So that way we can reuse that plus the error handling elsewhere. The second one is going to be the prepare statement. So SQLite 3 statement pointer, prepare statement, and we'll pass in const char star for the SQL. And that is this code here. We're going to generalize this, so passing in SQL there. Okay, so now I can just say equals self prepare statement, passing in this string here. And now we've cleaned up this code a little bit, where most of the code is just dealing with the looping over rows. And that's going to help our update to do here. So let's create our DB pointer, self open database. In this case, we're actually going to do some extra stuff to our parameters. SQLite 3 statement. Prepare statement. All right, so let's create our update statement. So we're going to say update to-dos set text equal to question mark. It's a good idea to, if you're not familiar with the SQL injection, this is not necessarily a platform where SQL injection is that big of a deal. But since we're actually letting users enter this data arbitrarily, they could, hose their local database, which wouldn't give them much, but maybe personal satisfaction. But it's still, SQL injection is a common problem. So you want to use parameters here and not try and concatenate strings in order to set the text here. So we're going to set the text equal to the first parameter and the completed equal to the second parameter. And of course we need to add our where statement where the ID is equal to the third parameter. Okay, so if you're not familiar with parameterized SQL statements, basically instead of substituting in the string values for this database statement, we're going to use some other SQLite bind parameters. We're going to say bind text. Now these are quite a bit different from what you would expect, so it's important to read the documentation on what these mean. We're going to pass our statement. The int is the position of the parameters, and this one is especially different because they start with 1. So 1 is going to be this one right here in front of our text parameter. Then we're going to pass in the value, which is a const char star, which means we need to take our to-do.text and we need to ask it for its UTF-8 string. Then n is the number of bytes in the string. We can use -1 for it to calculate it for us. And then this strange looking argument is SQLite transient. And that's just something that you'll use. It's important to read the documentation, but in general you'll use SQLite transient when binding string parameters. Okay, then we want to bind an int parameter for our Boolean value. So statement. This is going to be at index 2. And then we're going to say ns number. Actually, we can just say to-do.completed, and it should convert it over to the correct value. And finally, we have bind int. The last thing is at index 3, and that's to-do ID for our where class. Okay, we've bound our 3 parameters. Now we want to call SQLite 3 step and on our statement, which is just going to execute, and it's not going to return any data. So this time, instead of checking for SQLite row, we want to check for SQLite done. So we want to say if results is not equal to SQLite done, then some error happens. So let's go ahead and log it. One thing you can do is pass in a string here and look for the SQLite error message, which should give us the last error message that happened on that database. And again, that's going to return a C string, so make sure and use %s instead of %at, otherwise you'll probably get a crash. And if we get an error there, we should just go ahead and exit. Okay, let's make sure we don't forget to finalize our statement and close our database. And we don't need to return anything for this. Let's go ahead and build it and make sure we don't have any errors. We do. Let's give int declare that. And it doesn't know about our database. Oh, we need to pass in our database. So let's add a parameter for db SQLite 3 star db. And that means wherever we're using that, which is right here, we need to add a 4db db, as well as here. 4db db. Okay, so we have to pass in our database instance in order for that SQLite 3 prepare statement to work. Okay, next let's go ahead and go over to our TechPub to-do view controller, and where we're editing our to-do is this callback method here, to-do editor did finish with result. We have two cases. If the last edited to-do is nil, then that means we have a brand new to-do that came back from the plus button on our UI. Otherwise, they're just editing the text of that to-do. And then we have the other option of whenever we did select the row. Again, if we're going to do it here, this was going to update the to-do as well because they are editing that item. Okay, and let's check this out. Oh, and we have an error preparing the statement. So let's go ahead and take a look at our TechPub to-do, our to-do database. When we're preparing the statement, let's go ahead and add the error message. SQLite 3 error message. No such table to-dos. Well, that's interesting. Okay, so we do have a bug here where in our app delegate we made sure to call make writable database to make sure and copy the database over at the beginning of application did finish launching, and immediately after we add the subview for our controller. But at this point, this view controller was already created, and it was created by our nib file. So in reality, the creation of the controller is happening before the make writable database, and that's where we had chosen to do our initialization of our database and the to-do items array inside of the TechPub to-do view controller implementation file. So if we move that out of here, out of the initialization method, and into the view did load, at that point that won't be called until after the view is presented to the user, or immediately before the display is presented to the user, but after the application did finish launching event has already run. So this is a better place to put our database initialization code and our array initialization code. We see our array of items, and if we click this and check these, and let's go ahead and edit the last one. And we're done there. Now let's quit, and we'll launch the application again and make sure that all of these items have retained their values across application quits, and it does. So things are looking well. We still have not implemented the insert or the delete, so let's go ahead and speed through those quickly, and won't show you every single detail, but the same concepts are there. Okay, so I've gone ahead and added two more methods here, insert to do and delete to do, and the implementations of those are fairly similar to what we've already seen. We create the database, we create the statement. In this case, we're doing an insert statement, and we've got two parameters we need to bind to. So we bind the text parameter for the text and the int parameter for the completed. and then we execute it, make sure it happened. We have to do one extra step in the case of the insert, is make sure we get our primary key and set it back on the object. And to do that, we use another helper method called last insert id for DB, which is this guy here, and he's just going to execute a similar statement. Select the last insert row ID, which last insert row ID is a SQLite function that will return the primary key, the last thing inserted. So we have to do that, and then we again finalize and close to clean up. The delete is even simpler. We're just calling delete from to-dos where ID is equal to our primary key. We bind that parameter and then we execute it. Okay, so now that we have those functions here in our TechPub to-do view controller, inside the commit editing style function, this is where the delete is actually happening. So we pull the delete out of the array, we call delete on it, then we release and refetch the properties because it's actually going to call reload on the table data. So we need to make sure to-do items actually reflects what's actually in the database. And then for the edit, in the editing case right here, we actually, when the editing finished, to-do editor did finish with results. Right here we will update the to-do, and then here we insert the to-do. And again, we release the to-do items and reset it back to the fetch. So it's basically just doing another select to get the items in the database. Let's go ahead and run that and make sure that all of our functions are implemented. We can update text and completed status. And we can add new ones. And we can delete old ones. And if I quit and relaunch the app, notice that all of our changes have been saved. Okay, so SQLite is, as you've seen, quite a hairy API. It's not always fun to work with. In fact, it can be the cause of numerous headaches that you have. But there is light at the end of the tunnel. SQLite is actually pretty easy to work with as long as you leverage the right libraries. And you can either write your own based on the C API you've seen, or utilize something like FMDB, which I will show you next. Now let's take a look at a library that will help us utilize SQLite without actually having to deal with the strange C API that is difficult to work with. And we're going to take a look at FMDB, which is one of the handful of libraries out there. I find FMDB to be very easy to use, easy to get started, and it contains just a bunch of code that you wouldn't have to write in your own applications. So let's take a look at the same example using FMDB. It's at code.google.com/p/flycode. And if you take a look at the downloads for this, or the source code for this, there are a few different projects here, and one of those is FMDB. And I've gone ahead and checked that code out in my development iPhone libraries folder, FMDB. So I've got the source code here, and it contains, just a few classes. So I'm going to open that in Finder. And we have these classes here, and what we're going to do is just drag these into our project. So I'm going to create a new group here, call it FMDB. Then we're going to drag from Finder. You don't need this fmdb.m file, but it does contain some usage details. So sometimes I'll import it, but then comment the whole thing out because it contains its own int main method. So we'll drag those in here, and then make sure you check copy items into destinations group folder, and that's all we need there. Just to make sure everything is working correctly, go ahead and compile it and make sure you get green here. And okay, now let's take a look at the API. If we inspect the header file, we can take a look at some of these methods that you have. You have an open, you have execute update, execute query, you have some transaction management, some logs, and just a bunch of helper methods that can help you execute queries without having to deal with that low-level API. Okay, so what we're going to do is we have this to-do database class, and it contains all the functions that we want. And it's really the implementation file that we want to change. So what I can do is go ahead and inherit from that to-do database. We'll create a new class. We'll call it FMDB to-do database. We're going to go ahead and import the to-do database header file so that we can inherit from it. Now this guy is also going to import the FM database header file, and that's because we need an FM database instance, so we're going to call that DB. Now on the parent class, notice that it has a the database path and file name is noted as a constant here. So this DB path, we actually want to utilize this from the subclass. So I'm going to go ahead and just copy this and make it part of the header file so that we can utilize it from the subclass. Otherwise we'll get a warning saying it may not support this DB path method. Okay, so we're going to create our FM to-do database, and inside there in the init method we'll use the standard if self equals super init, return self, and then inside the if is where we do our own initialization. So at this point we can say db equals FM database alloc init with path, and we need to pass in self db path. And then of course, since we allocate there, we need to release it in our dalloc. So we'll call db release, and make sure you call super dalloc. Okay, so now we just need to provide implementations for these methods here. So let's go ahead and copy that, and we'll bring it over to fm-to-do-database.m, paste them in here, and we'll go to town. So the first one we'll do is this fetch to-dos method. Okay, so first thing we need to do is open the database, and then before we leave we should close the database. Then we can create an FM result set, which is going to be equal to database execute query, and we're going to pass in select star from to-dos. And we need an array to hold our results, so we'll create the immutable array to-dos, and we'll equal that to ns mutable array. So this one will actually already be auto released, so we won't have to auto release it at the end. Okay, so basically just want to loop over while rs has a next row, and the first iteration through will actually set you on the first row. Init, so set the ID to do ID equals int for column, and notice that we can pass in the column name instead of the index, which is much more helpful. Now rs text for column, or string for column, we'll pass in text here. Now we need to make sure that that guy returns an ns string, and it does. So notice how they're doing the conversion from the C string to the ns string for you. And to-do.completed is equal to rs bool for column completed. So Objective-C, now that we can see that the names of the columns and the names of our properties are somewhat similar. In this case it differs because ID is actually a keyword. But we could annotate this with a mapping file or something of the other sort, so that you wouldn't have to manually do this left to right code. And Objective-C is certainly flexible enough to do that. So if we had an object with, say, 100 parameters, we could come up with a smarter solution rather than writing all this mundane left to right code. Okay, so now that we have our to-do, we need to add it to our to-dos collection. And then we're done with this instance of to-do. Now the array is holding onto it. And then at the very end, we're just going to return our results. And we build and it passes. Now the other three are empty implementations, so they're not actually doing anything yet. What we can do now is in our TechPub to-do view controller, in our initialization, in view did load, we're creating our to-do database here. Instead of creating a to-do database, let's create the FMDB to-do database. And we need to import the header file at the top. Okay, and we have no issues. All right, so let's go ahead and run it. Now the only thing that we should see right now is that the initial load of the items should work, but currently is not. So we do have a bug in our code here. Let's go take a look and see what happened. Okay, so make sure that we close the result set here. Otherwise, when it gets deallocated, it might actually complain. And we should be able to run this code and see our items, and we do. So now let's tackle the edit and update functionality so that it will use the FM database class instead of the others. So we have update to do here. This is going to perform a similar function here. Open the database at the beginning, close at the end. And in this case, we actually need a different query that contains parameters. So we're going to say database execute update. And notice there's three variations. There's one that just contains the SQL, so no parameters. There's one that contains an arguments in array, where you pass an array, and a third that takes an array or a variable arguments list. And that may look a little strange, because if you use this one, the array is actually optional. So what you can do here is pass in your query. So this is going to be update to-dos, set text equal to question mark, completed equal to question mark, where ID equal to question mark. And then we can pass in our three arguments without labels. So just put a comma here, and then the first one is going to be our to-do.text property. The second one is going to be completed. For this case, we need objects. We can't use primitive types like int. So what we need to do is say ns number with int to-do.completed. Actually, this would be number with bool to-do.completed, and then we do the exact same thing, ns number with int to-do.to-do-id. And then we can close our bracket, and that should execute the update statement. Let's go ahead and build this and run it. And we will update this new one and say FMDB. Save it. Now we're going to quit and run the app again, and notice it is selecting and updating our updated FMDB to-do database implementation. Okay, so now we can sort of speed up and do insert and delete in the same fashion. And then we close it. So let's go ahead and build and run. So we've got our updating code working. We've got our inserted code, FMDB insert. And that works, and let's go ahead and delete this row here. And we'll quit and launch it again. And we have our updated code persisted in the database, and notice this code is a lot cleaner. So I would recommend taking a look at the SQLite C APIs just so that you can appreciate what's going on here. But in general, FMDB is so easy to use. I would recommend it for almost all SQLite applications. Okay, so those are two really pretty straightforward ways of dealing with data in the database. There's nothing to say that you have to use a database, but it is useful in scenarios where you do need to filter and query the data. In our simple example, this might actually be better implemented with files. You could represent this as any type of file that you want, a dictionary, plist, You could utilize an XML file or a JSON data structure, and you would just implement the appropriate writing code yourself. So it's whatever you're comfortable with. But in general, the capabilities of a database really shine when you have to do some sorting, filtering of the data, depending on what the user is doing in the system. One thing I've purposely left out for the sake of this discussion is core data. And core data is a really advanced concept for dealing with data in iPhone and Mac applications. Now, core data is built around independent structure of the data. So the underlying data store could be SQLite, it could be XML, it could be anything. And so you can treat core data as more of like a document database, and has limited support for things like querying and aggregate functions. So I would recommend to take a look at core data, and we may delve into core data in a later screencast. But in general, I tend to like to be closer to the middle, and I like working with SQLite directly. So I hope this one was helpful for you, and we'll see you next time.